Good morning, students. I'm going to conclude this semester's lecture by giving an overall outlining, giving a kind of an overall outline about what we have done so far and what is the real objective of this course. Okay. The first is that the fundamental aim or objective of this course is to identify the engineering problem. The very objective of this particular course is to come up with a kind of a novel engineering problem. Always one should remember that defining the engineering problem is always is being within the particular context, or it is highly contextualized in nature. Highly contextualized in nature. So this contextualization or contextualized in nature, which refers to a particular situation, or there are certain problem which occurs within the particular situation and how to address that particular problem. So it is highly situational. Highly situational, that means it is specific to a particular time and space. Maybe once you are able to address that situational problem, it can be applicable to elsewhere also. Okay, some other time, some other space, okay, you can apply those logics, you can apply those principles and to address the problems elsewhere also. Okay, so always you should keep it that it is highly situational in nature. At the same time, it has a notion of practicality. It is highly practical in nature. Okay, so that means we are trying to define the engineering problem from the point of view of practicalness than a theory. Okay, so then opening, what does this practicality means? What does this practicality means? How do we understand this practicality? Always remember that the practicality refers to the usability, number one. There is certain sense or certain aspects which, or certain technology or kind of a certain instruments you are trying to develop, that you can use it, put it into use actually. So the very definition, the very fundamental element of the engineering problem is that it is usable in nature. That means it has certain utility. The utility is defined in terms of function. It has to do certain function. Certain function. The function in terms of a purpose. So the very fundamental aim, the fundamental element of how do we define the engineering problem is that you have to think in terms of this. Number one, that means you have to clearly understand what is this situation is all about. Number one, that means that this situational understanding is what we call it as a kind of a user requirement, or the perspective of the user requirement. This is number one, the perspective of the user requirement. That means within defining the engineering problem, we are trying to understand the perspective of the user requirement. What is the user requirement? Okay. On the other hand, when you are able to understand, this is number one, and this is number two. When you are trying to understand the engineering problem from the point of view of the practicality, or from the point of view of the utility or certain function, usability in terms, that means you are trying to understand the engineering problem from the point of view or the perspective of the design requirement. perspective of the design requirement. These two are basically the first stage of defining what is said to be or what is supposed to be the engineering problem is all about. For instance, it can be, suppose if you are able to club this, for the perspective of the user requirement or the perspective of the design requirement. That means when you are understanding the user specifications, okay, this is what the users are, they are need of it. At the same time, what is the design specification is? The design specification is the one which gives you the instrumental views. This gives you the instrumental view of the technology. At the same time, this, when this comes to the perspective of the user requirement, it gives that how this instrument is going to work in a real field context or in a real situation, in a real time situations, how the instrument is going to work. How the instrument works in a real-time situation. So if you're missing these 2 points, if you're missing these 2 fundamental elements, that means you're completely missing the very idea of what is this engineering problem is all about. Okay, for example, this is what you translate in. For instance, you are trying to look at certain industrial production point of view. For instance, certain industrial production point of view. For instance, developing a vaccine. For COVID-19. Okay, so what you need is that you need the perspective of the user requirement. That means whether the vaccine will be a kind of an efficient, and whether it has an efficacy in it, so that it will be able to address the particular disease. So the vaccine is part of a kind of an industrial problem as well as the problem of the society at large. Suppose if you are trying to look at, for instance, defining the engineering problem from the research point of view. You are trying to develop a certain, for instance, certain microscope or certain instrument to understand what is the nature of a particular microbes is all about. So you are trying to develop certain instruments to understand the nature of microbes. So what is that? You're as an engineer, you are trying to develop this technology to understand the nature of a particular phenomena. So developing this instrument is also part of an engineering problem. That is, you are trying to use it within the research context or within the R&D, okay, research and development. At the same time, you can also visualize the engineering problem from the point of view of the industry. Or at the same time, there is a third one, you are trying to understand the engineering problem from purely as part of the organization point of view. Or you are trying to introduce new set of practices. So for instance, in the context of COVID-19, people used to say that everyone is supposed to follow the social distance. So if you go to the real market, okay, you will not be able to see that the people are going to follow the, for instance, the social distance. That means the norms are violated. If the norms are violated, then once again the disease is going to spread. So how do you make people to follow that particular practice, okay, in a everyday life? So that is also part of an engineering problem. Don't think that engineering problem is all about a technology alone. Engineering problem, to some extent or to the larger extent, it is also something which is social in nature, which is social as well as economic, as well as to some extent is cultural in nature. So I said this organization as well as the practice, introducing new set of innovative practices is also part of the engineering problem. But this is something which is left to to the social scientist, or for instance sociologist, or for instance some other disciplinary people who always try to engage with these practices in organization. Majority of the engineering problem is being defined within the technological realm alone. Okay, at the same time, which is more associated with the research context, or else it will be in the in the context of the industrial production. Okay. Another good example which I would like to give is that, for instance, you take a kind of a very kind of a primitive example. Primitive example is that it's a pulley example. For instance, someone has tried to come up with a kind of a particular device. That device is that it's supposed to reduce the pressure as well as the friction when you are lifting the heavy mass. Okay, so the mass is placed here. This is mass, as well as this indicates the weight. This is the friction, tension, friction, and here it's a friction. And what is happening here is that it's a force. The force which pulls the mass or the weight. Okay, so when it pulls the weight, what happens is here the entire pressure rests on this particular pulley. So it becomes very easy to lift as much as possible weight of the object. Okay, this is what particularly defining the engineering problem. So coming up with, for instance, within this you will be able to see the practicality. It has its own function, purpose. Okay, at the same time it is also usable in nature. If you ask the question that is it a theory? No, we have applied the logic of the theory. This is what the very fundamental part of the engineering problem is, that we apply the logic of the theory. Application of the logic of theory. Okay, for sometimes actually we develop in certain cases we develop the technology and then we start thinking that what kind of a logic which went into developing the particular technology. For instance, thermodynamics is a very good law of thermodynamics, is a very good example of this one. Okay, so keep this in mind that the application of the theory, okay, the application of the logic of the theory is to see this, ensures the usability, that ensures the functions, that also ensures the practicality. That's, we are trying to define all this usability, utility functions from the point of view or from the perspective of the user requirement or from the point of view of the situational requirement only. Okay, so this is what we have it at large. It's a very general idea of what is this engineering problem is. I'm going to put this entire frame in a kind of a table. It's a kind of a table which I'm going to put it. The first stage, this is stage 1. The stage 1, keep this in mind that the stage 1 is always, it's about the requirement. Always it's about the requirement. The requirement divides into two. One is user requirement, the other one is design requirement. The design requirement is about the technology, that's instrumental use. Instrumental view of this, and this exactly it's represented in a more kind of an academic language. It's about understanding and representation. Understanding and representation of a situation. Okay, this is the second one. It's about the stage 2. The stage 2 always deals with that once this requirement users are kind of the idea of the design, if you get it, then after that we will be thinking in terms of the performance. How the instrument is going to work, how the design is going to work, how the instrument is going to work from the user point of view. Okay, so that's about a kind of a performance. The performance in terms of like how it's going to work, whether it will work or not. Okay, so that's point of view of the performance. Then this is in academic sense. If you look at it, it's kind of an acting on the understanding and representation. Acting on the understanding as well as its representations. Okay, so this is how. So where the hypothetical questions, how we formulate the hypothetical question is that here we formulate the hypothetical question. Your hypothetical question comes at this stage. That means you are formulating certain hypothetical questions to know that what would be whether the instrument will work from the user point of view or not. That's more a kind of hypothetical questions. Suppose you will be able to have a kind of a different set of hypotheses. For instance, the hypothesis in terms of a cost, whether the hypothesis in terms of, for instance, like performance, efficacy, or you are trying to understand the efficacy, or you are trying to understand the efficiency of the technology. All this comes under the hypothetical question. Then the third stage. Stage 3. Always the stage 3 refers to the theories and laws. You are trying to use certain scientific theories or certain scientific laws. You are converting the scientific theory and laws into a logic of reasons or a kind of a tool or tools to, or even you can put it as always a theory is an instrument, okay, or a tool to understand, number one, the performance as well as the requirement. That means the theories and laws which helps you to evolve the hypothetical question. Okay, at the same time, this hypothetical question addresses the requirement, the users as well as the design requirements. Okay, this is how you have to think, how your theory is able to be effective in addressing the problem. At the same time, what could be the performance of that instrument which you are trying to develop. If there is no sequence, if there is no sequence of the order, that means if there is a kind of a disintegration between first stage and the second stage and to the third stage, that means it's not, the problem is not clearly defined. Problem is not clearly defined. For instance, you may, in certain cases, you may even test whether the particular laws which will work on certain situations or not, or certain theories which will work on certain technology or not. So these are all the things, the testings and all you will be able to do. So what is happening here? What is happening here is that this is purely these two interface between the stage 1 and the stage 2. Always this laboratory context, or it is the context of the laboratory. context of the laboratory in which we discuss about, in which we discuss or develop the idea or technology. Okay, this is the context of laboratory. But this is the context of application. Context of application of the idea as well as the technology. This is purely the context of application is about, it's purely you're taking it to the, you're moving your ideas from laboratory to the society. So the lab society interface could happen in a much more better way if you understand this logical order. If you miss this understanding of this logical order, it will be like very difficult for us to think an idea or a technology from developing from the laboratory to the society. So what is the thinking is that you have to always bring the larger understanding, the holistic understanding, the societal understanding within the laboratory, so that you could make much sense for your ideas, or you could make much sense for your whatever thought you have, innovative thoughts you have. Otherwise, the translation would be very, very difficult. So, I'm just coming to the conclusion of this concluding remarks is that this course, particularly HS 202 Science Meets Local Needs, is exactly locates at this point. Understanding and representation. The basic objective of this particular course is that it makes you to introduce, or the very objective of this particular course is that we will be able to take you to the field. We will introduce certain situational or certain context which we will be able to introduce it. So you are only like trying to derive certain knowledge. Always remember that knowledge is a kind of a representation. You are trying to derive that knowledge and convert that knowledge into a user format as well as a design format. Once you are having a kind of an entire idea on this level, then the performance, that means you are coming to the laboratory, you are trying to develop the technology. When you develop the technology, what you do here is that you are understanding the technology from the performance point of view, efficacy, efficiency, okay, the cost point of view, whether it works or not. So you are trying to judge all the kind of from nook and corner, you are able to judge and take decisions. That's why the hypothetical question comes. So the hypothetical question just links this 2-point understanding and representation, situations as well as the theory. So the hypothetical questions, which is the one, it becomes a kind of a via medium. This question becomes a via medium for connecting the first stage and the third stage. Okay, and finally, what is coming here is that if you are able to clearly represent and understand and represent the knowledge, that's fine. Then in the development engineering, this course followed by you will be like moving to the next semester. That next semester, which you will be you will be taking the course on development engineering. In the development engineering, you try to develop the technology. That developing the technology is that you are trying to connect it with this two. You are trying to connect it with this 2-point. Okay. Always remember that when you are connecting it with the performance theory as well as the representation, that means you are continuously mediating. That means like there is a kind of a regular communication, there is a regular mediation which happens between the society and the laboratory. What most of the time it happens is that we develop certain technologies within the laboratory in one point of a time, and we'll be thinking that okay, this technology would come in future, for instance after 1 year or 2 years, 3 years. By the time the things get changed, okay, the things get changed, and then we will be like in a different world, and it becomes a kind of whatever the efforts we have put within the laboratory becomes more discontinuous. Our efforts will not going to give any profit result or any positive results. Okay, if you want a positive result from your project, that means there should be a continuous engagement with your ideas, that continuous engagement at these three stages, at the three levels, you have to keep on continuously working. Then one point of a time you may be able to see your ideas or your projects which would able to solve bigger and bigger problems in the society. Okay, for instance, this COVID-19 would be a kind of not even a kind of an matter of concern. So that's what a kind of a more positive attitude towards whatever the problem comes. Okay, we will be able to solve it because we have become a kind of a problem solver. Okay, rather than a kind of a problem creator. The very objective of this course is to convert you to become a kind of a problem solver rather than a problem creator. Today, what is happening in the society is that most of the individuals are not able to accommodate or not able to develop the capability or thinking to become a problem solver rather than a problem creator. When you convert yourself to become a kind of a problem solver, the world is going to change, and the positive is always there is a kind of a hope in near future. Okay, keep this in mind and always be a kind of a problem solver. This is going to help you in future in whatever the problems comes to your life. You will be able to solve it. You will be able to face it courageously, and take this as a kind of an inspiration. This is something, a kind of an understanding is itself a kind of an inspiration for your life, and I hope everyone will become a kind of a very good engineers in near future. Okay, then you will be able to solve much bigger problems and you will be contributing to the society positively. Thank you.